Chris, and in this lesson we're going to take a look at 30, 60, 90 special right triangles. So if you've already watched our video on 45, 45, 90 special right triangles, then we're going to see something similar applied here. We're going to take a look at this general format, x, x root 3, and 2x, that shows the relationship between these three sides, and we're going to apply that to some specific questions. Now the slightly more challenging part of 30, 60, 90 right triangles is that all three sides are different, and we have to be very careful to make sure we keep track of where each side is located relative to the corresponding angle. Your 30-degree angle is the smallest angle in a 30, 60, 90, which means that the shortest side will be across from that angle. So here we see x is our shortest side, and then 90 degrees is your largest angle in a 30, 60, 90. So 2x will be the hypotenuse always opposite that 90-degree angle. And x root 3 is going to be right in between those values. It's going to be across from that 60-degree angle. So we want to make sure that we're very careful with where we place the corresponding sides in a 30, 60, 90 right triangle when we're applying this on standardized test questions. Let's take a look at a couple of examples. So this one shows 4 as the length of this side. And we have to say to ourselves, okay, this triangle is arranged a little bit differently than this one, so let's keep track of where the angles are located. If this angle is 60 degrees and this angle is 90 degrees, then that means that our missing angle here is our 30-degree angle, which means that opposite that 30-degree angle will be your smallest side, which corresponds to x. 4 is opposite the 90-degree angle, so that's our hypotenuse. That's the one that corresponds to 2x. So if this side is 2x, then if you were to solve for x, divide by 2, and that means that x equals 2, so your shortest side here will have a value of 2, and then your longer leg will have a value of 2 root 3 following this model that we have over here. Now let's take a look at one more example and see how we do with this one. So if we notice 5 is opposite our shortest side. So they're starting, 5 is our shortest side. It's opposite our smallest angle. So they're starting us off by giving us the value of x in this problem. And that makes matters a little bit easier. So once we know x, we simply plug in place of x for all three sides. Our hypotenuse will be 2 times x. And our longer leg will be x root 3. And to simplify this, 2 times 5 gives us 10. So we have 5 root 3, and mess that up, start over. Dang it. I can't speak, I can't write, I can't do anything. All right. Hi. I'm Chris, and in this lesson we're going to take a look at 30, 60, 90 special right triangles. These are triangles that will show up on a lot of standardized tests from PSAT to SAT, ACT, all the way up through GRE, GMAT, and some of those higher level grad exams. So it's important that we know the relationship between the three sides of a 30, 60, 90 right triangle. This is going to be slightly more challenging than the 45, 45, 90 special right triangle, because in the 45, 45, 90, 2 of your sides are the same. But here we see that all 3 sides are different, and we need to be very careful to make sure that we align them properly with where they're located according to the corresponding angles. The smallest side, x, will always be directly across from the smallest angle, 30 degrees. And the largest side, 2x, will always be across from your largest angle, 90 degrees. So be careful with that, and you should be in good shape for these kinds of questions. Let's take a look at 2 examples. Here we have this side of the triangle with a length of 4. And let's take a look at where that's located. It's located across from the 90-degree angle. So that lets us know, even though it's aligned a little bit differently than our model here, we see that our hypotenuse, the longest side, is always directly across from the 90-degree angle. So this is the side that corresponds to 2x, which means that if we were to solve for x, our shortest side, divide by 2 and we get x equals 2. So where do we put it? Well, let's take a look. Here's 60 and here's 90, which means our missing angle is 30 degrees. So your shortest side, which is x, will be across from your smallest angle. So this will be x on this side, which is equal to 2. And then your longer leg, when we plug in that value of 2 in place of x for our longer leg, we get 2 root 3 for this missing side. So hypotenuse is always double the shortest side, and for the longer leg, you simply take that value of x and you put it in front of root 3, and that'll tell you the 3 sides of a 30, 60, 90 right triangle. Let's try one more example, and let's see if we can do this one a little bit faster. So this is 30 degrees, which means this is our shortest side, which means this is x right here. So they start off by giving us x, which is kind of nice, because then we just plug that in front of root 3 on our longer leg, and we double it for the hypotenuse. So we get 3 sides of 5, 5 root 3, and 10 for that 30, 60, 90 right triangle. And in the case of standardized testing, which is where you'll see this applied quite a bit, it's really important that we can answer questions like this very quickly, because time is definitely of the essence on standardized tests. If you'd like some more practice, please feel free to watch some of our other videos on triangles, or you can visit our website at sandersontestprep.com. Thanks for watching.